Good morning, students. Today we are going to discuss about density-based clustering. So before going into this density-based clustering, let's talk about clustering. So what do you mean by clustering? Clustering or clustering analysis is simply we can say it is an unsupervised learning method which divides the data points into a number of specific batches or groups. So cluster means grouping only. So data points in the same groups have similar properties and data points in different groups have different properties. Like that we can subgroup it or cluster it. So we have many different methods evaluated in that, especially K means it's all about distance between points. We have affinity propagation, especially in affinity propagation what we will do, we will think about graph distance, right? Then mean shift in the sense distance between points. Then again we are having dB scan. So dB scan means nothing but distance, it's all about different distance between nearest point. Similarly we can talk about Gaussian mixtures. Then spectral clustering, again it's depends on the graph distance. So many methods are there, but basically this all clustering method is the same approach. That is, we calculate the similarities, and if they are similar properties they are having means we'll group into a single batch or single group. But today we are going to concentrate on the density-based clustering. So density-based spatial clustering, here especially when we have a data set with noise, we can go for this methodology. Okay, so we'll go deeper. So here in this density-based clustering, we have two major algorithm. One is dB scan, another one is DENCLO. So dB scan means nothing but density-based spatial clustering of applications with noise. That is what called as dB scan. I'll repeat it again. Density-based spatial clustering of applications with noise. Okay, so whenever we have abbreviation, we need to expand it with highlights. Then, so we'll see one by one. So especially in this density-based clustering method, clustering happen based on density. So in the sense, local cluster criteria. What we are having here criteria is density. So density connected points are explicitly constructed density function. Based on that, we will identify the density and we will cluster it. So the major feature here is it discover clusters of arbitrary shape. It handle noise. We can use scan facility. Then we need to focus on density parameters also. So apart from this, we are having similar methods like dB scan, DENCLO, optics, click, etc. So the major scientists who are all concentrate on those algorithm also mentioned here. So we'll go see it later stages. So now we will focus on dB scan. As I said earlier, in this dB scan, it's all about density. So it's a density-based algorithm. So here density in the sense number of points within a specified radius. So suppose we have a entire space, in that within a radius or within a region, what are the points there? Based on that, we can identify the density. Okay, then here we need to focus on 3 points. One is core point, another one is border point, another one is noise point. So we'll see what is core point, what is border point, and what is noise point. So a core point means nothing but if it has more than one point has more than one specified number of points within EPS, within the density, within the radius means, then within the radius means we can say it is a core point. These are the points that are at the interior of the cluster. So usually this core point will always present inside or interior of the cluster. Border point, it is has fewer specified number of points within the DPS, but it is in the neighborhood of the core point. So from the name itself, it's actually in the border. So border point. The noise point now, that is actually outside the cluster. So that is noise. Any point that is not a core point or a border point, we can call it as noise point. So whatever points we are not able to classify either under core point or border point, we can call it as a noise point. So these are the things we need to focus when we talk about this density based algorithm, especially dB scan. Then see whatever I explained, that is mentioned in this diagram very clearly. So you can see that in this graph you can easily identify what is the core point, what is the border point, and what is the noise point. Just go through it. Then here radius is taken as 1. That's why it is they mention as EPS equal to 1. Okay. and see the blue dots are mentioning the point. So which belongs to inside the circle, we can say it's a core point. If it is on the border, we can say border point. If it is outside, we can say it is a noise point. Okay. Then, so the algorithm, simplified algorithm is given as a steps. So totally 7 steps are there. I'll just read it out so that you can understand. So whenever we need to do this deep scan algorithm, we need to create a graph first. So graph means definitely it's a collection of nodes, and nodes are connected, right? So automatically here nodes means nothing but the points to be clustered. So that is called as nodes. For each core point, let us take core point as C. We have to create an edge from C to every point P in the particular neighborhood of C. Then only we can able to create a cluster, right? Then set n to the nodes of total number of nodes. Let us assume that it is n. If n does not contain any core points, we can terminate it. Otherwise, we have to pick a core point from that collection of nodes present in that group, that is C, and we have to compute the cluster. That is, we are identifying whether the set of nodes can be reachable from C going forward. So if it is reachable, then it is completing the limit of the radius. Okay, so these steps we need to repeat until we need to find the all the points. So here again I'm just explaining with one diagram. See, go through the diagram. We have a original points, but here all the points are mentioned in blue color. That is, here we are not classified into whether it is a core point, border point, or noise point. But here in the second diagram, it's very clearly classified which one is core point, which one is a border point, and which one is a noise point. So the noise point is actually represented with red, and core point is green, and the border point is blue. Okay, so that is just for identification dimension. And this is the way we, by implying algorithm, we can able to create these things. And when DB scans works well, we can easily identify, we can create several clusters. So with the similar properties, points will be there in a particular clusters, and we can easily do the classification. So that is the best thing about this DB scan or density based algorithm. Why the specialty here is, here we are focusing on noise function, noise also. So automatically we can able to resistant to noise, and we can handle clusters of different shapes and sizes. That is another one important. It's not like only circle or only square or something like that. We can handle any shape of clusters. So that is another specialty of this algorithm. And but when the points are very, I mean, they placed very near, and there is, we can't able to classify it in way means, or automatically this method will get failed. So that is the disadvantage, because we are very densely, all the points are there, even the similar properties, non-similar properties, everything is there in the same space means it's very easy to, it is very difficult to classify. So that is the one of the drawback. And so high dimensional data is the bigger threat in this DB scan algorithm. And noise points have the hey nearest neighbor. So here also we can identify the hey nearest neighbors algorithm concept, so that we can able to identify the distance between points, and it in turn help the formation of clusters. That is also possible. And the complexity, when we talk about the complexity, time complexity of this algorithm is order of n square, whereas the space complexity is order of n. So whenever we are writing any algorithm, try to write the complexity value also. Here n represent number of objects that should be clustered. So that is called n. So we'll just summarize this algorithm. So as I said, it's a density based clustering algorithm. It can detect arbitrary shapes, not very sensitive noise, supports outlier detection. Complexity is kind of okay here, but beside K means the second most used clustering algorithm is this density based clustering algorithm, that is DB scan algorithm. So the con or bad part here is, it does not work well when in high dimensional data. As I said earlier, so the data is very high, very high dimensional data set, then it is very difficult to work. Then parameter selection is very tricky here, and it has a problem of identifying clusters of varying density. So that is the another one drawback. But nowadays we have several refined algorithms that is going to overcome this algorithm. I mean, overcome these drawbacks. Okay. Then density estimation is kind of simplistic, but it does not create any real density function, but rather a graph or density connected points only it's creating. So these are the minor drawbacks, but later stage several algorithms they developed, and using that we can able to overcome these drawbacks. Okay, that's all.